You know, every great building, every skyscraper, starts with a blueprint. It has to. Well, for software, that blueprint is something we call requirements engineering. And it's the absolute first, most critical step that really decides whether a project is going to be a huge success or just a very, very expensive failure.
And when it goes wrong, oh boy, it goes spectacularly wrong. Just look at the FBI's virtual case file project. This thing was supposed to totally modernize their data systems. Instead, it was canceled after burning through hundreds of millions of dollars. The culprit? You guessed it, vague, incomplete requirements. The blueprint was a mess from the very beginning.
And it's not a one-off thing. Remember the infamous Denver International Airport baggage system? On paper, it was this engineering marvel. In reality, it was hit with just massive delays and crazy cost overruns. And the root cause was exactly the same thing. The teams were trying to build this incredibly complex system based on a set of requirements that were just unclear and always changing.
So why are these failures so incredibly expensive? Well, it all comes down to a really fundamental principle in software known as Bohm's Law. Put simply, it just says that the later you find a mistake in the process, the more it's going to cost you to fix it. A lot more.
And this chart, wow, it shows you exactly what we're talking about. If you find an error way back in the requirements phase, it's cheap to fix. It's just a conversation, right? A quick change in a document. But find that same error during testing, the cost jumps up. And finding it after the software is already out there, deployed to your users, the cost absolutely skyrockets. This is exactly why getting that blueprint right from the start is completely non-negotiable.
All right, so if requirements are the blueprint, what exactly are we even talking about? Let's get a really clear definition of what a software requirement actually is.
So, at its very core, a requirement is basically a condition or a capability that a user needs to solve some kind of problem. It's the formal way of saying, here's what the software absolutely must do, here's how well it needs to perform, and here are the limitations it has to work within.
Now here's where it gets really interesting. There's this crucial translation that has to happen. We start with what we call user needs. These are high-level, kind of general goals from the user's point of view. Like, I want an easy way to find my photos. But, you know, a developer can't build from that. Those needs have to be translated into super specific, measurable, and testable system requirements.
And we can break these down even further into two big buckets. First, you've got functional requirements. These describe what the system does, its features. A classic example is the user can log in with a username and password. Simple. Then you have non-functional requirements, or NFRs. These describe how the system performs. This is all about its qualities, things like speed, security, and how easy it is to use.
And honestly, these NFRs are often the real difference between software people absolutely love and software they just put up with. See, saying a system should be fast is useless. A good requirement says the system will handle 1,000 transactions per second. Instead of just secure, it gets specific. All user data must be encrypted using AES 256. That level of detail is what prevents disasters down the line.
Okay, so we know what these things are. But how do we get from some vague idea in a meeting to that level of super specific documented detail? Well, it happens through a structured, 7-step engineering process. Let's walk through it.
Think of this process like a roadmap. It takes us all the way from that first little spark of an idea to a living, breathing document that guides the whole project. As you can see, it flows really logically, from discovery to refinement and negotiation, before you finally write it all down and then manage it over time. Let's break down what's actually happening at each of these stops.
The first chunk is all about discovery. Inception is where we ask that huge question, what problem are we actually trying to solve here? Then, once we have that basic idea, we move to elicitation. This isn't passive at all. We are actively going out and gathering all the detailed needs from everybody involved, the stakeholders, using things like interviews and workshops to make sure every voice is heard.
Okay, next up, we have to refine all those raw ideas into something we can actually build. Elaboration is where we dig into the nitty-gritty details and clarify everything. Then comes negotiation, and let me tell you, this part is absolutely crucial. This is where we have to balance what's ideal with what's actually possible, sorting out conflicting requests to figure out what's most valuable. Finally, specification is where it all gets written down in that formal blueprint, often called a Software Requirement Specification, or SRS.
And the final phases are all about making sure our blueprint is sound and then protecting it. A validation is the big quality check. Are these requirements correct? Are they complete? Can we even build this? Then, requirements management is the ongoing job of tracking and controlling any changes. And this is so important because change is going to happen. A good process for managing it is what keeps a project from just spiraling out of control.
But here's the thing. Just having a process on paper isn't a magic bullet. There are some really common pitfalls that can derail even the most well-intentioned teams.
And what's really interesting here is how these challenges are all connected. They create a domino effect. If your requirements are ambiguous, you're going to get an incorrect implementation. If the requirements are constantly changing, you're going to get endless rework and delays. It's a vicious cycle.
And that brings us to maybe the most notorious project killer of them all, scope creep. This is that dreaded thing where uncontrolled changes and just one more little feature are constantly being added to the project. Before you know it, the project has ballooned in size, your deadlines are shot, and the budget is gone.
So, how do we stop this from happening? Well, a huge piece of the puzzle is bridging those communication gaps. Instead of just handing over a 200-page document and hoping for the best, smart teams use things like prototypes. It gives people a visual, something they can touch and feel. And holding regular meetings where developers and users can just talk directly, absolutely essential to make sure everyone's on the same page.
This constant need for better communication and more flexibility has really pushed the industry towards more modern, agile ways of defining what a system needs to do.
So, instead of that massive, formal document that's written in stone, a lot of Agile teams now use what are called user stories. They're just simple, informal sentences written from the user's perspective. Something like, as a shopper, I want to save items to a wish list so I can buy them later. They're light, they're focused on the user, and they're way easier to adapt as the project evolves.
And this brings us right back around to where we started. This modern idea of shift-left testing is a direct answer to Bohm's law. It just means we're pushing testing activities as early in the process as humanly possible. We're not just testing code anymore. We're actually testing the requirements themselves to make sure they're clear and correct before anyone writes a single line of code.
So, at the end of the day, it doesn't matter if you're building a massive government system or a tiny little mobile app. The principle is exactly the same. The blueprint is everything. So the question I want to leave you with is this. Your project's blueprint is being written right now. Is it clear enough to build on?